Alright, so the rate of change of a linear function is how quickly the y-axis variable is changing relative to how quickly the x-axis variable is changing. So it's a kind of ratio. And if you, alright, don't worry about that. I'll explain that. So um, let us find the rate of change of this function, which is a function of distance in miles relative to time in hours. Okay, so the steps are this. Pick 2 points that are on the graph. So I'm going to pick this one because that's really nice and easy to see what it is. So my x coordinate is 5. This is on the time is 5 hours, and then the y, the distance is 120 miles. Okay. Just ignore that crazy line that appeared out of nowhere. Okay. Let's pick one more point. This one looks nice. So x is 3, and the y is 70 there. Okay, so we've got our 2 points. And what this formula for the rate of change is saying is find the differences of the y's and divide that by the difference in the x. So this y2 minus y1 business is take your first point and take your second point, subtract it from the first point, etc. So we'll call this that was the first one I got, but let's just call it the second one. It doesn't really matter as long as you do it in the same order for both the x's and the y's. So 120 minus 70 is 50. So my change in y is going to be 50 miles. Okay, because I took these 2 points, I subtracted 120 miles from the first point from 70 miles in the second point. So that's 50 miles. And you do the y's on the top. So y is on the top of the ratio. Okay, now let's subtract the x's. So for the y's, I went this way, 120 minus 70. So for the x's, I'll do the same thing this way. So 5 minus 3 is 2 hours. So the change in the x is 2 hours. And I can simplify this. 50 over 2. I could reduce that down to 25 miles. Sorry, that's kind of messy. That says miles. Here, let me write that. Let me just write m for miles. Yeah, okay. M. There we go. And then 1 hour. So that's my rate of change. 25 miles per 1 hour. So that means the y's, the distance, are changing for every 1 hour. They're changing. They're going up 25 miles. So the rate of change here would be 25 miles per 1 hour, or as we would say, 25 miles per hour. So you can actually see, for problems like this where it's related to time, the rate of change is actually what we would call speed. So if I'm graphing my distance away from something relative to how long I've been driving or biking or running, the rate of change of that function would just be the speed.